Hello, everyone. Welcome to the AI Agents Hackathon live streams.
The AI Agents Hackathon is a free virtual hackathon running from April 8th to April 30th.
We're hosting over 20 live streams where you'll learn how to build agents using various Microsoft technologies. At the end of the 3 weeks, submit your project for a chance to win fantastic prizes.
And now over to our friends at Reactor.
Hi, everyone. Thanks for joining us for the AI Agent Hack. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our speakers for today. Thanks for joining.
All right. Hey, guys. My name is Anush. I'm a PM on Azure Communication Services. Today, I'm supposed to be talking to you about building voice agents in a multimodal way with Azure Communication Services. So I'm not much of a slides guy, but what I am going to do is just do a quick level set. I think some of the slideware will help. So I want to just talk to you about what is Azure Communication Services, how are we an AI-enabled communications platform, and then how you can use it to build a bunch of different cool things with AI. So first thing I want to talk to you about is what is ACS? And so many people are probably familiar with us as a communications platform in a way that may not be canonical. So ACS and the underlying services that power ACS are actually the same communications primitives that we make available to Microsoft's products and services like Microsoft Teams or Microsoft Dynamics. And then what we do is we repackage that for you as developers to be able to create your own applications that are based on these communications modalities and primitives. So this could be an example of building a very simple sort of SMS-based chatbot, or it could be more sophisticated, like setting up a global telehealth service using our VoIP and video calling suite, or it could be something even more sophisticated, like building a fully fledged contact center with routing and rules and real-time media and orchestration using our telemetry stack and routing stack. And so what's really cool is you can choose from any one of these, pair them together, and make them available as developer SDKs. And you can even do fun things like hand off in a multimodal way from an AI-enabled voice agent to something that uses SMS or chat to follow up asynchronously like that. And then what we also make available to you is integrations with something called AI Foundry. AI Foundry is a relatively new service as of late last year, 2024. And what we do is we make available a series of models as well as tools and services to help you build AI-enabled applications. And so this includes things like your standard developer tools and SDKs, as well as the underlying foundation models and reasoning models, as well as a bunch of different things that enterprises need to be able to deploy these things to conduct business workflows, like being able to do RAG and search on their underlying content, or be able to ensure content safety, do data tagging, observability, and even things like data loss prevention in certain cases. And so what we do is we basically make available the developer SDKs for ACS, and we also pair them with some of the AI models that are available in Azure OpenAI and AI Foundry, and enable you to do fun things together with them that you might be able to not be able to do if you were just trying to build them in a bespoke way. And so, like I said, I'm not much of a slide guy, so let me jump quick over to a demo. What I want to show you is this right here. It's a GitHub sample. You have it accessible in the chat, and if you have questions about it while I'm going through the session, please just put messages in the chat, and I'm happy to address them once we get to a good breaking point. But I'm going to flip back over to Visual Studio Code, and this is the entire sample running in my Visual Studio Code environment. It's actually VS Code Insiders, so I've got this cool GitHub Copilot agent mode here on the right-hand side to help me if I get stuck on anything. There's a couple different components. The first is the main.py file, which contains the basic Python web server. Then there's the communications handler, which has my system prompt for something called Recipe Finder. And so Recipe Finder is a sample that I built because I'm a busy dad. Oftentimes I'm driving back from picking up my kid or driving to picking up my kid, and I want to be able to figure out what to make for dinner. And so this is a sample that I built that allows me to call a 1-800 number and tell it, hey, I've got these ingredients. I kind of have a rough idea of what I want to make. Can you just remove the cognitive overload of just trying to figure out what to make for dinner based off of these 2 or 3 ingredients that I might have, and then sort of help me wing it. And then what I've also built is sort of a recipe finder class, which uses the Bing Search API to go on to crawl the web to find the thing that I am looking for based off of the OpenAI Real-Time API's understanding of my conversation flow. And so the first thing I'm going to do is I'm going to go ahead and call DevTunnel host here in my terminal. For those that are unfamiliar, DevTunnel is a Azure service that allows me to take my development environment and make it available in a secure way to the public internet. And so this URL right here is basically a running functioning URL for my local service. And then what I'm going to be able to do is call my Python web server and have it run locally. So what it's doing now is it's spinning up a web server using Unicorn, which is a Python web server. It's calling my Python files and iterating through all the directories and making this local server available on the public internet. And so what I'm going to do is I'm going to call this 1-800 number. So I'm going to jump back over to my phone over here, move it over to this side so you can see a little bit better. Oops, there we go. And what I'm going to do is I'm going to call the 1-800 number like so. You should be able to hear it.
Welcome back, Anuj. Great to have you here. How can I assist you in finding a delicious recipe today?
Hey, good morning. I've got ground beef and broccoli in the fridge. Can you help me find something to make for dinner tonight?
Good morning, Anuj. Let's see what delicious dish we can whip up with ground beef and broccoli. Any particular cuisine you're in the mood for, or any dietary preferences I should keep in mind?
I don't have any dietary preferences or restrictions, but I do want to make something Asian inspired tonight.
Perfect. I'll look for an Asian inspired recipe with ground beef and broccoli. Do you have any common pantry ingredients like soy sauce, garlic, or ginger?
Yeah, I have all those pantry ingredients.
Great. I'll find a recipe that uses ground beef, broccoli, and those pantry ingredients to make something tasty and Asian inspired. Let's get cooking.
Okay, great. And so what happened just then was it used it uses OpenAI function calling to be able to get the recipe from the web that I wanted to search for. And you'll notice that I didn't actually have any code in there to figure out, so the recipe is actually right here. I'm gonna go put that over here. And so it sends me a recipe to my SMS on this side right here. And so that's super cool. I can start off with a voice conversation and I can transition to SMS, because what's actually happening is it's listening to my voice, and it's using a voice-to-voice model called the Real-Time API, the OpenAI Real-Time API. And it's basically taking the voice and the content of my voice, it's turning that into a voice-to-voice model content in byte array. So it's basically shuffling those bytes to an OpenAI real-time model and saying, oh, here's my understanding of the ingredients that you have on hand based off of the system prompt that I provided it. And then the agent's job is basically to go figure out a recipe that might meet the criteria that I've specified in the conversation flow. And so what's distinctly different about this is it's not speech to text, text to speech. It's not me saying something, them turning it into text, and then the model sort of operating more like a chatbot. It's basically saying, hey, if I'm excited about a recipe or if I'm confused, it'll use the intonation of my voice, the contents of my voice, the specific tonality of my voice, and turn that in a reciprocal way into the agent's response with a content understanding of what the substance of it is that I'm saying in the form of text. But it's a representation. It's not true text to speech and speech to text. And so this has two benefits. First, it can respond in an empathetic tone if I'm really upset, or if I'm really excited, it can reciprocate with like a very excitable sort of tone. And then the other thing it can do is it can do things in real time. So I can interrupt the agent if I want to. I can clarify my ingredient list. I can ask it to change the cuisine type. I can do things in real time that I wouldn't be able to do if it was just simply transcribing the text, sending the payload over to the internet, and then sending it back down to my telephone line. And so the way this works is actually quite simple. I'm going to go here to an Excalibur, like a very naive drawing. You've got my phone over here, and it's basically dialing into the Azure Communication Services infrastructure via this API incoming call. And I have this API incoming call method exposed in my local development environment. And so your production application would also have that in deployment, such that we could let you know, hey, there's an incoming call, you need to respond to it. And you could, at that point, do what I like to lovingly call shuffling bytes. And what shuffling bytes basically means is you're basically taking the media, the ones and zeros from the phone call, and you're shuffling that over to a voice-to-voice model. In this particular case, it's the Azure OpenAI Realtime API. And once OpenAI has those bytes, it'll reciprocate with a bunch of bytes back that you can send back via ACS all the way back down to the telephone line. So you're literally just going through this loop of telling the AI model what ones and zeros you want to send it, and the AI model is then sending ones and zeros back to the telephone line. And then those ones and zeros are getting via ACS, via the communication services, being turned into audio that you can then play back on the PSTN line. And so that's the naive way of doing this voice-to-voice interaction. But what it's also doing is listening for things that it needs to go do that have been pre-programmed. And this is called function calling or tool calling. What this enables us to do is basically system prompt events or callbacks that we want the model to be able to trigger off of. And so the two ones that I've set up are basically, hey, find a recipe and then send an SMS about that recipe that you found. So I ask it, hey, I've got these ingredients and I want you to go find a recipe. It's been programmed to go through a conversation flow in natural human language to say, hey, you need to go ask the user what kind of ingredients they have, what kind of cuisines they might be interested in, what kind of dietary preferences or restrictions they might have. You want to be cheerful. You can look through the system prompt on the GitHub sample. And then once it has enough information, it'll go tell the user, hey, I'm going to go find a recipe for you. And then once it finds it, it's going to respond back and say, hey, I found a recipe on this website, and then ask, would you like me to send you an SMS? And then if the user responds with an affirming message, like, hey, yes, I think that sounds great in natural language, it will then trigger a function call again to say, hey, I need to send the SMS to the number that the user called from as an implicit assumption. And then it'll send the SMS with the recipe link saying, hey, hi from Recipe Finder, this is the recipe requested, and then provide the recipe link that you asked for. And so let's jump over to the code and I will show you how it works. So like I said, I've got this API incoming call method. And what this does is just basically tells me, hey, there's a coming call and I need to respond to that media or respond to that event saying, hey, I've got an incoming call. And the way I have that set up in Azure is I basically have this right here. I have a phone number that I've set up. And I've also gone over to the event grid aspect of it, where I have my new event grid subscription for the API incoming call. And I've got this method set up right here. Let me just reload this because I may have messed it up. Let's see if it modified the system state because I didn't save anything. Yeah, here it is. So over here, I've got my dev tunnel with API incoming call down here set up to where once I get the incoming call, it'll notify my local development environment or my production deployed environment. You can see very recently I had a incoming call 3 times in the last couple of minutes, and then another one just now that we just placed for the purposes of the demo. And so when I go over back to my code, I've got this incoming call method. And then the other method that I've set up is API callbacks with context ID. And what this is the meat of the conversation. It basically notifies me, hey, there's a call connected, and we're going to start pumping media to you that you can then send to Azure OpenAI. And what's really cool about this is it's actually really simple. You just respond to a web callback, a webhook callback, and you send that media over to Azure OpenAI, and Azure OpenAI will respond back with media that you just pump back down to the client. And so once you have that set up, what you can do is go back over and set up your system prompt and say, hey, you're a chef assistant. You can actually change this in real time if you want to. Actually, I'm going to do this with GitHub Copilot. I'm going to wing it and say, hey, change the system prompt to be more cheerful. And you'll notice that I'm using agent mode and I'm using Claude 3.7 Sonnet. You can literally just make it do respond however you want, and GitHub Copilot in this particular case will take the system prompt text, iterate through all the code and say, hey, I want to make this more cheerful. So let's see what it comes up with and how fast it can do it because we're on the clock running a quick demo here. Let's give it another couple seconds. Great. And so it says, hey, you're a cheerful and enthusiastic AI assistant, blah, 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 delicious recipes. Friendly, it adds things like, hey, exciting and friendly, lots of warmth, enthusiasm, dash of culinary passion. And so what's really cool about this is you can completely change the tonality and the content of the messages based off of what you want. And then I often will actually, as a PM, ask a Copilot to write specifications or system prompts for me. And in this particular case, it does a great job of updating the guidelines to be more cheerful and enthusiastic and excited and positive and delightful. I'm going to back out all these changes because I don't necessarily want it to be super exciting, but you can do something fun things like this. And so the other thing I wanted to show you was over here is basically a recipe finder class. This is a simple recipe finder class. And if I was doing this, I built this before the responses API, which I'll talk about here shortly. But this is just a mechanism for me to call back using function calling. So function call. It basically comes in here and says, hey, get recipe, when it recognizes that the model says, hey, go get the recipe. And then it calls this recipe finder class with the find recipe method right here. It says, hey, once the model says, hey, it's time to go get a recipe, I'm going to go call this method and await it and get the recipe finder response, and then provide that recipe back down as, hey, there's a recipe here with the recipe I found for you here. So it's super, super simple. And then the send SMS is very, very simple. Send the recipe is another function call, and then we call the send SMS method, which is just a simple send SMS from Azure Communication Services with SMS.send using the SMS client, which you see here on line 348. So super easy. There's not a lot to it. You're just basically calling a couple methods to orchestrate the send and receive responses. And so the other thing I wanted to show you was the mechanism by which we integrate with Azure OpenAI. So there is this WebSocket right here, which basically says, hey, start a conversation. When you receive the data for the conversation, which is the bytes, this is the JSON with a byte array inside of it, just send the audio to Azure OpenAI. And this is the communication services and the communication handler. That's basically the full integration with Azure OpenAI. They expose two different endpoint types. One is WebRTC, which is really, really useful if you are in variable connectivity environments. So if you're in a rural environment, or if you are having, like, if you have a mobile web app or a native mobile app where you want to be able to respond to changing network conditions, you can implement a WebRTC endpoint and facilitate that interaction with Azure OpenAI. It makes it to where it sort of variably reduces the quality without disconnecting the call. And we also support WebSocket, which is a less sophisticated implementation, but it's a more general purpose one, and certainly easier to implement. Okay, so that's the demo. Let me transition to some updates around some of the model capabilities in Azure. And then if there's any questions along the way, I'll follow the chat in the comment section here. And if anybody has any other any other questions, that I'll go ahead and monitor the chat here in just a second. So actually, this is a good time to do this. So people say hello from Florida, hello from Redmond. This is great. Love to see all the people here. Pamela just posted the sample in the chat. Thank you for doing that. MKG asks, I assume we can use other real-time models using ACS in the OpenAI model. Yeah, you can. So remember, if I go back over here, this WebSocket is just Python code. You can do whatever you want with it. And so remember, in AI Foundry, we're pretty agnostic to which foundation model you use. You can even, or a reasoning model you use, or voice-to-voice, or any kind of model you want to use. You could just update this to say, hey, I've gotten data on a WebSocket. I want to receive that data from the phone number, from the client phone number, and then I want to pump that data to some endpoint. You can pick which endpoint you want. You can use 11 Labs if you want to. They're a great sort of speech-to-text, sort of voice-to-voice as well as STT, TTS model. And it also enables you to sort of change the, give you optionality, but also change the cost equation when you have sort of higher value customers or customers that don't ask simple questions. So if you have a customer who's very sophisticated, who has sophisticated needs, and you want to use a very sophisticated model at higher cost because that customer is super high value, VIP client, you can go do that. And then if you need to, you can degrade the quality for somebody who doesn't really need the sophisticated models, and do that in an interesting way. And then I'll also talk to you about the mini model that we've implemented in AI Foundry that gives you some additional cost savings. Let's see here. So we have a global, Pamela asked, we have a global ID for the call connection. Would this need to be re-architected to work across multiple users? Yeah, so you would basically have a state system. You have a state machine that would basically keep track of callers based off of their call connection ID. So if you had multiple callers, you need to have a mechanism of sort of an async database, like something that could asynchronously handle, hey, there's a call that's come in, update the database using some sort of transaction, get the call connection ID, maintain it for the purposes of the call, and then sort of pop it out or update the state when the call is over. We do a little bit of that for you by virtue of the service sort of handling the call connection ID and sort of giving you a new one. But you'd certainly have to, if you were developing sort of a production class application with multiple clients calling in at the same time, you'd want to be able to have a state machine of some kind, probably a database that would be able to have transactions to update the system state. Wagner, last one, Wagner asks, in the Copilot window, where agent is selected, clock 37, notice the red exclamation point icon. Why is it like that? Does it indicate that it's the MCP server is not connected? Good question. I was playing around with this cool service called Get MCP. This actually, you're exactly right. It is a MCP server for GitHub documentation that is not started. So if I start the server, actually this is not my MCP server for Git MCP. It's for the Claude application locally. It's for a weather MCP server that I built a long time ago. It doesn't actually impact the prompt that I gave it in agent mode, because agent mode didn't call that MCP server. It didn't get the right function callback to call that MCP server. So it doesn't actually impact the job that I gave agent mode to go do. But it is an issue where you will basically see, hey, there's an issue with MCP for the MCP servers you set up locally. If you want to set up an MCP server and have it sort of be kosher with whatever you're doing with agent mode, you'd want to go set it up that way. Okay, I'm going to talk to you about some enhancements in the service. And if there's other questions about what I'm talking about this session, please jump in. This stuff changes so quickly, so I think it's useful to talk about what's happening in the world of like these service deployments. There's a bunch of new models. So let me just take a step back. We think about the world through the context of foundation models. These are your like GPT-3s, GPT-4s, and then now 4.1, 4.5, 4.1 mini, 4.1 nano. These are things that you give it a prompt, it responds back with as much information. You can give it a bunch of information and respond back with whatever much information it needs to match the performance. And it's, we basically scale up and down from the ability to provide sort of very high enhanced instruction following with large context lengths to something that's like very, very scaled down, like low latency. You can imagine that doing this would be useful for an IVR where you want to be able to go have multiple agents in the background, respond to a master agent that's a voice-to-voice model and say, hey, here's a function callback, go call this other GPT-4o nano agent to go figure out how to go, do a password reset and then come back really quickly because it understands how to do that sort of really quickly at low cost. So in a scaled implementation, you might want to scale all the way down to the nano models, but for something that's more of a chatbot where it's not super low latency, like low latency is not an issue, you could implement a fully fledged model. And then we're also releasing 4.5 preview, which you can get access through gating process by searching for Azure OpenAI GPT-4.5 preview. It is really useful, and I found it to be really good for writing PM specifications. So like you'll notice that in agent mode, I asked it to update the system prompt whenever I want to write a PM spec. Some of these sort of enhanced models that are focused on intuition and writing style, sort of knowledge transfer, these are really good things. And so an example of in which people have used this in customer-facing or business-to-business interactions has been for password reset documents. If you need to basically take a bunch of data sources, collate them together, and write a very succinct, concise way of doing password reset, they will basically go to SharePoint documents and sort of summarize all of them into a single document that links out to those very specialized documents. And this is useful for like any sort of IT help desk task. And so I would imagine a lot of people would be able to include the summarized, concise PM documents, IT help desk documents in the context of a customer-facing model that would be able to say, hey, if you've got an issue with password reset, here's the document you should use. And then if you have more specific instructions that need to go step by step, you can go link out to this other thing in the IT help desk knowledge base. This is distinctly different from reasoning models. You'll notice that when we used Claude, or we use GitHub Copilot agent mode, a lot of these systems actually rely on reasoning models that can do sort of chain of thought or step-by-step logical reasoning. So an example of this would be when I go say, hey, build me a Python application that connects to Azure Communication Services. It will basically go through and say, okay, I need to think about all the things I need to go do to build this system that the user has asked for. And so it'll basically go do coding tasks. It'll go do project management tasks. Like I have to go figure out the deployment stuff, like go do deployments to Azure. So that's like, it'll go through all of these steps and give you sort of a step-by-step reasoning with summaries, as well as tool calling, whether it's an MCP server or calling out to the terminal to execute sort of a Azure CLI command. This is what reasoning models are really good at. This is what makes them particularly good at agentic workflows like coding and reasoning. And so a lot of the stuff in GitHub Copilot agent mode, like the Gemini 2.5 Pros, the Claude 3.7 Thinkings, these models that you probably heard of in the context of GitHub Copilot, these are like very advanced reasoning models. And so in the context of coding scenarios, I highly encourage developers to go use these. And in the context of Azure Communication Services, I highly encourage people to think about using them when you have sort of agentic workflows. So password reset, I'm just going to sort of harp on this. Being able to tell a user, hey, my password isn't working. That's kind of a naive instruction set. What you really want to be able to do is say, okay, let me think about all the things that could possibly be wrong with this user's access issue. And then say, hey, here's a couple of common issues that the reasoning model has thought about based off of its context about you. And that's when reasoning models are really good, is it sort of is an iterative conversational partner, not just a one-shot, hey, what is the capital of France? It's really good at these reasoning scenarios where it needs to kind of figure out what your intent is, provide summaries, maybe call a workflow via MCP or some sort of function calling, and then get back to you with information that you might be able to use to narrow down or drill down on what the issue is. And then we've also got these lower cost models that are more generally available now. There's no gating behind them. And so it's really useful for being able to do low latency, advanced reasoning at very low cost. I'm going to jump back into the questions because I just said a bunch of stuff about AI models. Does ACS provide recording feature like regular contact center solutions? HJ Lee asks. Yes, we do. We provide a couple of different things. We provide call recording. We provide call streaming. And then we also provide systems where you can connect them into teams and implement data loss prevention and compliance features. So if you are building a banking financial advisor application and you want to be able to redact social security numbers or PII that's been set in the meeting, we give you the ability to integrate with M365 capabilities to redact any of that information. You can also do that using a developer SDK by taking the call transcripts, taking the chat history, and be able to redact that information using a deterministic natural language model like Azure Language Services offers, or even using an LLM that's less deterministic, but can understand specific instructions that are provided about the kinds of information you want to be able to redact. So this is really useful. Ravi Singh asks, how is observability and evaluation done for real-time voice agents? Good question. People generally want to know operational metrics in the context of voice agents. It's like, how fast is the call over? Did the customer get their issue resolved? Do they have any other questions? You'll probably, when you call a 1-800 number for a company, you'll probably hear them say, hi, my name is Jennifer. What can I help you with today? And then you tell them what your problem is. And then they go through the issue and say, hey, let me go back to this SharePoint site and try to search for the issue that I'm trying to resolve for you and come back to you. And then when they resolve your issue, they'll say something like, is there anything else I can help you with today? They're generally interested in these operational metrics, but companies are actually also interested in your satisfaction and call latency. How long did it take you to connect? Did you have any hiccups with the call? Are you getting your question resolved in a timely manner? And then also they're interested in how many turns of the conversation you have. So if you call in, you provide a prompt, like, help me figure out this issue, and the person has to go through 5 different knowledge bases and a lot of sort of digestion of data and processes. They're very interested in why that call took 30 minutes. So there's a lot of telemetry that we allow you to pump into the system, either via the AI system or the communication system, or just Azure Monitor if you want to. And then we also make available Copilot capabilities for you to ask natural language things like, what were the top 10% of highest latency calls? Which geography did they originate from? Were there specific issues with the Azure infrastructure associated with this call? And so you can ask Copilot to do all that fun stuff for you. Let's see here. Where can we download the deck? I'll get back to you on this with Pamela. And then Pamela's also linked the GitHub project as well. So I'm going to move on to a couple other interesting things, which is the responses API. I think you'll notice that in my code sample, I use something called the Bing Search API. And the responses are basically a way for me, what I would have been able to do is basically use the voice-to-voice agent, the voice-to-voice model with the real-time API, along with the responses API via the function calling. I know there's a lot of buzzwords and new concepts, but basically it's a way of saying when I need something done, like web search, I can go do fun things like web search, as opposed to writing deterministic code. Where I'm basically saying, I'm going to go call this bespoke workflow in a custom way. The responses API lets you bake in tools that you would want to use, and the OpenAI model lets you execute those tools in a way that's sort of fully integrated, as opposed to sort of in a fuzzy way, thinking about web search as its own separate thing for a sort of idiosyncratic workflow. And then the other thing I'm really excited about is something called computer use agents. This is something that a lot of our customers are excited about, which is being able to have a phone conversation, right? And then have the agent send you an SMS and say, hey, I'm having an issue with my password reset. I'm on a PSTN line, but I've got an SMS or a WhatsApp message that's been sent to my endpoint, and I need to be able to go have the voice agent guide me through the access issue. And so what it can do is it can, in my browser with the link that I've sent it, have it go sort of encourage me to go through the normal flow that would cause my issue, observe it, and then articulate next best actions that would help me resolve the issue. And so it's a combination of being able to sort of in the browser, apply commands to an isolated, secure, compliant browser, as well as recognize what's on the screen. So in this password reset example, it could be something like, hey, I'm getting an error when resetting my password because my password does not meet the specific criteria for numbers, special characters, password length, etc. You could have the OpenAI agent, for a less sophisticated, sort of maybe older user who doesn't understand what any of that means. You could have the OpenAI model say, oh yeah, you're not understanding. You need to be able to articulate, you need to have these specific criteria met in order to be able to reset your password. Maybe somebody did it for you before, but you're resetting it now, and you need to be able to do this. And they can do that via natural language via the phone call, as opposed to flipping back and forth between a sidecar web chatbot and the browser that you're currently in. It's a much more intuitive experience for you to just be on a phone call and in the background have the phone call going, but then show the agent what's happening live in real time. It's a super cool sort of next generation, both consumer as well as business to business capability that I'm super excited about. And then these are all powered by the communications capabilities that we've been talking about, whether it's sending an SMS or sending an email to be able to enact these workflows, or having a voice agent via VoIP or PSTN in the back of the conversation, sort of observing and interacting with you in a natural language way. It's a super cool way of elevating these sort of crazy, sort of boring, simplistic interactions to something that just very quickly gets the job done. I'm going to pause for more questions. There was a question around WhatsApp. So WhatsApp is a special beast. It's part of our unified messaging SDKs. It's a way for you to be able to get access to a single SDK to be able to say, hey, irrespective of which modality the customer comes in through, whether it's SMS, email, WhatsApp, we're going to give you the ability to integrate with any channel that you want. And what's cool about this is you can go in and say, hey, I want to start my conversation via WhatsApp, but I want to maybe I'm traveling to or start my conversation via SMS in the US and then transition to a conversation via WhatsApp, whatever channel I want. Could be email because I don't have SMS in the country that I'm traveling to. You can design interactions that are incredibly sophisticated to meet the customer where they're at in whatever context they're at. And so WhatsApp is a capability that's currently offered via messaging. I don't have anything to say about calling or voice right now, but there is the ability, I believe, in the messaging SDK to be able to get voice notes and use the voice notes for asynchronous sort of voice notes to be able to understand what's in that interaction. Murillo, I hope I'm pronouncing your name correctly, Murillo Farias, asked a question about the number of tokens. Your final number is only after you finish the conversation. Yeah, so the way, actually, let me just go over here. Don't want to do this. Azure OpenAI Real-Time API pricing. So you can go over here, and the way Real-Time API is priced is actually per batch of tokens. right here. So, oops, real-time API. So it's actually priced really differently than what you would expect, which would be for a chat-to-chat, like a chat completions model or foundation model, where your input is number of tokens. For audio, we price you on number of million tokens for the audio. The way you calculate audio, I don't actually know. Cached input versus output, I don't actually know. But the way this works is you basically get a batch of tokens. I imagine that tokens are not specifically tied to the number of characters in the text, but rather the number of tokens that are calculated by the model for the audio that you send to the OpenAI real-time model. You just look at this for the metering that's available there. It's different per region that you deploy the service in, but for text, it's different. One of the things I didn't say is that actually in the real-time model, you support text as well as audio input output. The reason why this is important is because in certain scenarios, you actually want the chatbot to be in real time scanning the text so it can go do things like RAG. No, I don't need specific help right now on pricing. And so this is really important in terms of having the best possible user experience for real-time scenarios. So you can imagine a scenario in which, hey, I want to buy car insurance and I'm providing the chatbot with information about me and my specific needs. Instead of the chatbot going to some enterprise knowledge base or some enterprise workflow engine to price my car insurance, and it takes 5 or 10 seconds to call that database and call that API, they can in real time be scanning the text that I'm typing in and then going out and getting information in real time. So it feels like more of a fluid back and forth conversation as opposed to, let me get back to you in 30 seconds once I've had the ability to call 10 enterprise APIs behind sort of this gateway. And so you can go to this pricing page and sort of start to price out what this would be. I actually personally, what I like to do is I like to copy and paste this page, throw it into a language model like ChatGPT and say, hey, my contact center gets about 20 million calls per year. The average duration is about 5 minutes. Can you help me price out what this would look like for the rest of calendar year 2025? And I'll look at this information and say, hey, based off of the information you provided to me, it looks like it might cost about this much for the telephone line, for the real-time API. Azure infrastructure probably like this kind of class of VM, and the network cost would be this. And so it's really quite sophisticated going to do that. I believe we're launching a copilot for Azure Calculator as well at some point, but throwing in this pricing is really challenging. So I encourage you to use all the fun AI tools to price this out for yourself. So hopefully that answers your token question. And then the last thing I want to talk about is agents. Agents are really interesting. There's 50 different agent frameworks and SDKs out there. They're all fun and interesting in their own specific ways. The thing I want you to know about is with AI Foundry, because ACS is integrated with AI Foundry, and we provide both disparate SDKs as well as integrated SDKs in certain ways, you can rely on AI Foundry to meet sort of your whole agentic AI world needs, and then integrate in a secure, compliant way with all of your existing Microsoft investments like SharePoint and Fabric and even blob storage. But then also rely on it to do sort of the authorization, authentication, integrate with third-party services like ServiceNow, et cetera, and then rely on to be able to give you the best-in-class models, whether that's something like DeepSeek or even the Azure OpenAI services that we offer bespoke. And then because you've made that investment as like sort of your one-stop shop for AI Foundry, you can plug in various channels, whether that's PSTN, VoIP video calling, even a sort of a web application, whatever it is that you need, because you've got this central one-stop shop for AI Foundry. And I think that's really cool because we also make available to you various SDK methods to be able to expose those investments that you made in AI Foundry to various other workflows. So I was using just real-time API. In a future world, you could use the Agents SDK with Foundry to, instead of rely on function calling, you would use sort of just like an integrated AI Foundry function callback method, that much cleaner developer experience, to be able to do things like, hey, when the customer wants an SMS sent, just have much more succinct code because AI Foundry with its LLM is recognizing you want to call this method. Super cool, interesting way of getting access to everything you would need to build an agentic world, an agentic application, all in one-stop shop. I'm going to go back over to questions and scroll through here. Pamela posted the docs for WhatsApp. Thank you for doing that, as well as information on the tokens. I think we figured that out. I'm running up on time, and so I wanted to just very quickly mention one other thing, which is Real-Time Mini. So we basically launched, as of, I believe, 2 months ago, a very low-cost iteration of the Real-Time API that I provided to you in the demo at roughly 1/4 the cost, depending on which region you're in. And the trade-offs, you get to do the same things you want to do with the full model, which is real-time audio interactions, natural speech generation, and be able to speak in English, and then maybe you have a partner who only speaks Spanish and English is a second language. It'll respond back in Spanish based off of your prompting or the conversation. You can do all the things you would do with the standard real-time API, but what you can also do is do it at lower latency, at lower cost. And so this is really useful for scaled deployments. We've heard from customers that we don't need some of the advanced reasoning that some of the real-time API provides. We don't need the higher accuracy. We mostly just need really low cost at scale deployment to conduct business workflows. And so if you go look for the Real-Time Mini API, which is still in public preview, but I believe I'll check in with the build team to figure out when that's going to ship. But it's going to be a much lower cost for you if cost is a concern if you're thinking about doing it at scale deployment without a lot of compromises based off of the data that I've seen in terms of how it performs for some of these voice agent scenarios. So I'd highly recommend you check out and for your own needs sort of benchmark what that would do for you in terms of cost savings, because I don't think cost should be an issue when you're getting a lot out of these AI models to be able to do the things you want to do for your business or even for your B2C workflows. I'm going to pause there again. I think I'm nearing the end of the session. The things that I want to show you is, if you're curious, there's another demo here on YouTube on the M365 developer channel with links to information on the docs for ACS as well as the GitHub sample. If you want to reference back to this, I'll go ahead and paste that in the chat. And if there's any other questions, I would invite you guys to jump in the chat and ask questions as well. I don't see anything popping up, so I think this is a good time to. Oh, Marco has a question, probably a little off topic, but can I build the same agent you did, but instead of using AI Family, using Copilot Studio? Good question. So yes, you can. There is code here in the sample that I published to GitHub where you can find the recipe using Copilot Studio. Check out that code, see if it does anything for you. We think that Copilot Studio has two values. One is making it super accessible and easy for anybody, even non-developers, to build agents via chatbots, whether it's voice agents or chat agents. And so that's something that's amazing and accessible to you. But if you don't, there's also authoring workflows that are super interesting for you. So check that out. And then MKG asks, does any of the ACA services available for POC purposes of an independent consultant and don't need aid of using ACS services? Yeah, you can just use your standard MSDN subscription or an Indie subscription that you have. The service is publicly available. All the stuff that I've shown you is available for developers of any sort of scale or size to use. And I would encourage you to try it out. If you have any questions, please reach out to us. We'd love to engage with you. H.J. Lee asked this question about outbound scenarios. Outbound and inbound are exactly the same. I would encourage you to go to the sample and look at the APIs. When you make an inbound call, it's just like responding to a webhook. When you make an outbound call, it's just creating an API call from your Python or whatever developer environment you have to place the outbound call to whatever phone number you want. Oh, right. I don't see any more questions popping up. What I maybe would do is after the session, we can sort of respond to questions async via the comments, and I'll jump back into the comments in the YouTube channel or the live stream and respond to questions and monitor those. I really appreciate you guys' attention and time. I think this is, I've been excited about being able to do stuff like this for years in ACS, and with some of the enhancements with AI Foundry and Real-Time API and some of the amazing work we're doing in Azure OpenAI with reasoning and foundation models. This stuff is just so super simple. Even a PM like me can write voice agents in less than 1,000 lines of code even without any assistance from GitHub Copilot. So it's a really fun, exciting new world. I'm really excited to see what you guys build with these amazing technologies. Thanks for watching.
Hi, everyone. Hope you enjoyed today's session. If you aren't registered for the AI Agents Hackathon yet, Register now at aka.ms/agentshack and start hacking on the agent of your dreams.
And if you have any questions along the way, just post in our GitHub discussion forum or attend our live office hours in Discord. And of course, make sure that you keep attending the live streams to keep learning about agents.
Once your project is ready, submit it before April 30th at 11:59 p.m. PT to be eligible for our prizes. Thanks for joining.